Alright, so earlier on we discussed the definition of solid wastes and its effects, and I also discussed the physical and chemical compositions of solid wastes. Now, um, we're gonna tackle the solid waste management hierarchy and its elements. So this is the solid waste management hierarchy. So this hierarchy ranks the various management strategies from most to least environmentally prepared. So we have prevention, reduction, recycling, treatment, and disposal. So prevention contributes the most um, solid waste management, and disposal contributes the least towards the solid waste problem. All right, so prevention is generally there is no solid waste there is no solid waste produced within the process. So this is the most ideal, since if there is no solid waste, then there is no solid waste problem. All right. So since this is very unlikely in a process, so the next uh, the next method in solving the solid waste problem is reduction. Right, so source reduction. So we have these common industry practices. So we have materials reduction. So reducing materials initially used. For example, like plastic bottles before are generally different from the plastic bottles we have right now. So one of which is its cap. So the cap before is generally bigger than the cap in our plastic bottles right now. Also, the plastic bottles before are also thicker, uh, has a thicker material compared to our plastic bottles these days. So it's thinner and very generally more flimsy than those of before. All right, so that's an example of materials reduction. We also have material substitution. So this substitute waste materials to more usable or biodegradable ones. So for example, the use of eco bags or reusable eco bags instead of plastic bags. So we substitute the plastic bags or these plastic bags to eco bags. Also, using um, what you call this, using utensils, reusable utensils instead of the disposable ones. All right. There is also a uh, new innovation where, since we are in an era that you know we always online shop, and so parcels need plastic and to cover up these items for delivery, right? So there is an innovation where they use a biodegradable um, packaging for these parcels so that it will be more um, environmental friendly. We also have the lengthening of life. So the lifespan of a certain solid waste or a potential solid waste can be increased as to reduce solid waste as much as possible. So this is to increase the reusability of a certain material so that it will not go to waste as often. So if one item has a longer lifespan, it means that it will also reduce solid waste, reduce its chances of being a solid waste, right? So that's also one of the practices in the industry. Next is we have recycling or segregation and recycling. So when our solid wastes are recycled and segregated, it is easier for us to identify its um, methods of disposal or recycling. Alright, so for example, in this photo, we have recyclable waste or di nabubulok or non-biodegradable. So these are commonly plastic bottles and such. Okay, so these are non-biodegradable and recyclable. We also have nabubulok or biodegradable. So these are compostable waste. Generally, these are food wastes or waste that decompose. We also have um, residual waste. So these wastes are commonly wastes that cannot be recycled anymore and needs to be disposed of. All right. Next, we have treatment or recovery and treatment. So resource recovery can be classified into two. We have material recovery and we have energy recovery. So in materials recovery, so this is generally also recycling. For example, paper or newspapers can be used again to make more paper. Like this is called paper pulping. We also have composting or biological reprocessing. So food scraps and other biodegradable materials can be turned into fertilizer. And this fertilizer will be brought back into our plants and crops. And so the cycle goes on. We also have energy recovery. So we have already tackled this earlier on. We have incineration, pyrolysis, biodigesters, RDF or refuse derived fuel, and landfill gas extraction. All right, so let's take a look at composting and how it's done.
Have you ever thought about where your leftover food goes after you throw it in the trash? Or the consequences that it has for our planet? In the US alone, about 37 million tons of discarded food were brought to landfills in 2015. That's equal to the weight of 100 Empire State Buildings. In landfills, food scraps and other organic material are broken down by bacteria in the absence of oxygen, which produces methane, a potent greenhouse gas with even greater capacity to trap heat in our atmosphere than carbon dioxide. Composting is an eco-friendly alternative to discarding our food waste with three important advantages. First, composting allows food scraps to degrade in the presence of oxygen, meaning no methane is produced. Second, composting mimics natural nutrient recycling processes, breaking down biodegradable materials to produce organic fertilizer, a sustainable alternative to synthetic fertilizers that require high amounts of fossil fuel energy to produce. Third, composting diverts waste from landfills, preserving natural ecosystems that would otherwise be cleared for landfill use. And the best part? You can compost in your own backyard. Click the link in the description to learn more.
All right, so that was composting. So generally, composting um, uses biodegradable materials like generally like food scraps. So these are also solid waste. So composting makes use of these food scraps and other decomposable materials to make fertilizer, generally fertilizer, and sometimes also produce biogas. So we'll learn that later on. in the industry, or let's say at home, so one compost pit could cater to at least 500 persons. So this one compost pit is 1.2 by 1.2 by 1.8 meter in size. So it's generally really small, but it could accommodate 500 persons. So imagine landfills that uh, landfills will be replaced with compost pits. So daghan kay taog magamit na area sa landfill compared to a compost pit. But generally, a compost pit or composting is only for biodegradable materials. All right, so um, non-biodegradable materials like plastic and sometimes paper or other materials that are non-biodegradable uh, are not suitable for composting. So this is an example of compost pit. So we have stacking materials. So we have twigs and leaves, we have old newspapers, sawdust, and weeds and grass cuttings at the top. So if you adding nitrogen or adding nutrition like the food scraps and you add water, it promotes composting. It decomposes and it becomes fertilizer. Then you can use it for um, fertilizer. You can now use the compost as a fertilizer. All right, so there are no wastes generated. So in the industry, we have different types of composting. So this is usually in the agricultural or farm industry. So we have a windrow. So this is windrow composting.
How do we maintain 16 to 18% oxygen in these very large composting windrows? Doing this requires two things. First, an understanding of how air moves in a compost windrow, and secondly, an appreciation for the need for enough porosity in the compost material. The way aeration works in a regular compost pile is that as the core of the pile heats up, that hot air wants to rise, and as it rises it creates a vacuum, drawing cold air in from the side. As we increase the size of the windrow, this gets much more difficult because there's not enough oxygen in the core to create those high temperatures. The solution is to provide aeration. By placing a 4 to 6 inch diameter pipe underneath the bottom of the windrow, we achieve two things. First, we add oxygen to the core of the pile, which allows that pile to heat up and create that vacuum required to draw cool air in from the side. Secondly, the force of the air coming up through the pipe creates a bit of an aspiration effect where it also draws in cold air from the side. The result is that we can provide 16 to 18% oxygen in very large windrows using a very small centrifugal blower. In this particular case, we have windrows that are 30 feet wide, 15 feet high, and up to 120 feet long, and they're aerated with a 1/2 horsepower centrifugal blower. The energy and air requirement for a similar quantity of composting material in an aerated bunker or extended aerated pile would be dramatically greater. So we can see, by understanding the dynamics of how air works in a composting windrow, we can produce a high quality compost, maintain very high oxygen concentrations, reduce odor for a minimal cost. My name is John Paul. I'm a waste management scientist and compost specialist. Thank you.
All right, so that was windrow composting. So generally, it is a stacking of compost materials, and wind or oxygen is introduced inside the compost. So it feeds the decomposers or the bacteria inside and promotes
How
decomposition.
do we maintain
And
16 to
CO2
18%
or hot
oxygen
air
in
goes
these very
up.
large
So this is
composting
what we call
windrows?
the windrow
Doing this
composting.
requires two things. First, an understanding of how air moves in a compost windrow, and secondly, an appreciation for the need for enough porosity in the compost material. The way aeration works in a regular compost pile is that as the core of the pile heats up, that hot air wants to rise, and as it rises it creates a vacuum, drawing cold air in from the side. As we increase the size of the windrow, this gets much more difficult because there's not enough oxygen in the core to create those high temperatures. The solution is to provide aeration. By placing a 4 to 6 inch diameter pipe underneath the bottom of the windrow, we achieve two things. First, we add oxygen to the core of the pile, which allows that pile to heat up and create that vacuum required to draw cool air in from the side. Secondly, the force of the air coming up through the pipe creates a bit of an aspiration effect where it also draws in cold air from the side. The result is that we can provide 16 to 18% oxygen in very large windrows using a very small centrifugal blower. In this particular case, we have windrows that are 30 feet wide, 15 feet high, and up to 120 feet long, and they're aerated with a 1/2 horsepower centrifugal blower. The energy and air requirement for a similar quantity of composting material in an aerated bunker or extended aerated pile would be dramatically greater. So we can see, by understanding the dynamics of how air works in a composting windrow, we can produce a high quality compost, maintain very high oxygen concentrations, reduce odor for a minimal cost. My name is John Paul. I'm a waste management scientist and compost specialist. Thank you.
You have you have a vacuum inside, and that is where the decomposing happens. That is where the oxygen comes in, and hot air or CO2 goes up. So that is windrow composting. We also have a rotating drum composting. So it is generally the same, but it rotates in a drum so that oxygen inside the drum or oxygen inside the compost material is evenly distributed. So producing good compost materials. All right. So generally, in composting, the nature is have its way in decomposing materials. But for example, in a biodigestor, it uses anaerobic digestion or without the presence of oxygen. And so these materials you produce methane. And so this methane or this biogas, for example, as you can see here, so there is waste produced, for example, from the market, and then this is fed into a digester. So in the digester, the sewage sludge decomposes and produces methane gas. So this methane gas is fed into a storage area or methane storage, or it is turned into electricity. And so the solids, on the other hand, becomes the compost and eventually becomes a fertilizer. All right. So this is a biodigester. Digester. So this is how a biodigester works.
In the spring of 2013, the Saskatchewan Research Council built a biodigester for the Canada Agriculture and Food Museum in Ottawa. SRC created a small-scale model of a biodigester, a system that converts farm waste into energy. Manure from the farm is put into the tank, where microorganisms ingest it and produce methane gas. The methane is collected at the top of the tank and moves into the bladder, which looks like a big bag. When the bladder is full, it releases the gas, which can be used as a source of energy. Back inside the tank, the leftover product is called digestate, which can be removed from the tank and used as fertilizer. The biodigester is a truly sustainable concept. It turns a waste product into energy and fertilizer and is a tool that can help farms across Canada become more environmentally friendly.
Alright, so that was a biodigester. So next we have, since those are usually methods in which uh, decomposers or biodegradable materials are decomposed, there are also non-biodegradable materials that need to be disposed of. So these are the methods of disposal. So this is at the bottom of the solid waste management hierarchy. So we have landfilling, ocean dumping or reclamation. So this ocean dumping and reclamation is only for construction debris only. All right, so we also have surface impoundment, salt dome formation, underground cave, and injection wells. So those are some of the methods of disposal of solid waste. So let's focus on the most common, which is the land filling. So before that, there are such thing as open dumps. So if you know the Smoky Mountain in Tondo, Manila, so it is supposed to be a landfill, but you will know later on why it is not. Alright, so it was actually just an open dump. So generally, open dumps are open. So they have minimum effort and expense, but it is unsanitary and smelly, and it promotes vermins and pests in the surrounding areas, and it contaminates soil, water, and air, and is a fire hazard. So you will know later on why it is a fire hazard. So this is an open dump area. All right. Now, in a sanitary landfill, so generally these days, open dumps should be replaced with sanitary landfills. So each day, trash is spread in thin layers. Then they are compacted down and covered with a layer of soil and graded for drainage. So for example, step one, unload the solid waste and it's spread into thin layers. And then these layers are compacted and covered with soil. All right. So these sanitary landfills have largely replaced open dumps. So this is the explanation or an example of a sanitary landfilling.
A sanitary landfill is an excellent method of solid waste management. Initially, a large pit or depression is made by the removal of topsoil. It is then lined with a synthetic plastic in order to prevent leakage from waste materials. This is called a bottom liner. Garbage wastes are dumped into the landfill and properly compressed using specialized machines. Pipes are inserted in order to drain off liquid materials that ooze out following compression. Methane gas produced by the decomposition of wastes is collected into separate pipes. This is done to prevent explosions. The methane may now be burnt to generate heat and electricity. Daily wastes are covered by layers of clay and topsoil in order to prevent exposure to the air, pests, and to prevent a foul smell. Specialized storm water pipes are fitted to divert and control water runoff from rains and storms. This is an ideal method for the disposal of solid wastes.
Alright, so that was sanitary land filling. Alright.
A sanitary
So there are minimum requirements in a sanitary landfill. So we have first, um, at the bottom, we have the at the top of the before we before the garbage or the trash is put into the landfill, we have the top liner. So this material, this top liner, actually prevents any leakage of leachate or the liquid materials that come from the solid waste. So on the top of the top liner, we have the primary leachate and collection removal system. So next, at the bottom, so we have the primary leachate collection and removal system. Then we have the top liner. And we have the top liner. Then we have a leak detection system, secondary leachate collection and removal system at the bottom of the top liner. So in case the top liner fails to prevent the leachate from leaking, there is another leak detection system at the bottom. So that also collects any leakage of leachate. After that, at the bottom, there is a low permeability soil. So this soil has low permeability, meaning any leachate that is not taken by the secondary leachate collection and removal system, it is hard to pass through this per low permeability soil. All right. So that is basically the minimum requirements of having a landfill. So do you think the Smoky Mountain have these? So the Smoky Mountain in Tondo, Manila does not have these. However, if you do your research, the Smoky Mountain has already improved, and some solid wastes have already been transferred to different sanitary landfills. Alright, so there are three common landfill methods. We have the trench method, area method, and the canyon depression method. So the trench method is one of the most common. So it creates trenches. So there are just like this. Also, this is the original soil here. So it creates a depression and it's dig deep under. So this is flat. Alright, so this is where the liner is. So this is the trench method. Okay, so this is a cross section of the trench method land filling. So we have the liner here. This is the liner. And we have monitoring facilities under and leachate collection pipes here in between. All right. So this is an example of a liner. So this is usually HDPE is used. So this is very effective in leachate containment. All right. So this is generally what happens in a landfill. So on the topsoil, we have on the top or the one that covers the landfill, we have the topsoil, sand, and clay, then the compacted solid waste. So there are different probes to detect methane leaks and leachate monitoring and groundwater monitoring wells. All right, so here you see there is a methane gas recovery. So pipe, um, this pipe goes to the methane storage and compressor building and eventually the electricity generator. So there is also a leachate pipes here. So as you can see here, there are two leachate collection systems. So we have the primary and the secondary. So one at the top of the liner, which is this blue one, and one at the bottom of the liner. All right. So this is generally the sanitary landfill. So we also have the area method. So it's actually the same. It has all the requirements, all the um, facilities, trench method landfilling has. But instead of having a depression or uh, the soil is dug deep, so the area method has embankments at the sides, which holds the area or which holds the um, solid waste, the compact solid waste, and it is actually like a mountain. All right, so this is a murag a mountain siya na na landfill. So instead of having to dig deep, it goes at the top of the native soil. All right, but there are earth embankments at the side for the solid waste to keep its shape and will not spread. All right. So we also have the canyon depression method. All right. So this canyon depression method is in a slope. All right. And it's like a stairs na pababa. So this is an example of the canyon depression method sanitary landfill. So we have the liner here. This is the liner. And this is the original ground. So generally, it is like making stairs, right? So this is the working cell. So this is the most recent, the recent, what you call this, the recent trash or recent solid waste that is brought to the landfill and is then covered with um, soil, topsoil, and clay. So the leachate system is at the bottom. So what's good with this canyon depression method is that the leachate goes in one place. So it only needs little pipes since nara siya paubos man siya tanan. So all the leachate goes down. And so the leachate system, collection system, is only at the bottom. So unlike in the trench and the area method, so unlike adto nga, the pipes, the leachate collection pipes are spread uh, along the area gyud sa the whole area of the um, along the whole area of the landfill. All right, so this is a main difference. All right. So properly designed sanitary landfills, they prevent water infiltration and leaching of toxic fluids. So I've been mentioning a leachate. So what is a leachate? So it is a liquid that has passed through or emerged from solid waste and contains soluble, suspended, or miscible materials removed from such waste. So more siya og liquid nga gikan sa atong garbage. So usually naaman ay kauban nga mga liquids. So since our garbage is um, compressed in a sanitary landfill, so liquid coming out from it is called leachate. So this can be harmful to our groundwater system. So properly designed sanitary landfills prevent water pollution, reduce vermin pests, and reduce smell, toxic gases, and fire hazards. So first off, prevent water pollution. So, since ang sanitary landfill, it has a leachate collection system, primary and secondary, and it also has um, probes or wells that monitor groundwater systems. So, it could prevent water pollution. It also can prevent vermins and pests because the area is covered. Alright? Unlike an open dump, dili siya covered. So, daghan jud mananap nga mag-spread. So, it also reduces smell, toxic gases, and fire hazards. So, the same way with the smell. So, since it is covered, so smell cannot penetrate sa atmosphere. And as well as toxic gases and fire hazards. So, since it also, a sanitary landfill also has a methane collection system. So, this methane is the fire hazard. So without the collection system, so a fire could start anytime in a landfill without the methane collection system. But the problems with landfills, so it requires a lot of space, and it produces the methane gas that can be used for energy or can cause climate change. So from the video earlier, methane is actually a is very harmful sa atong atmosphere. So without proper collection system of methane in sanitary landfills, it is quite dangerous. Leachate must be collected and treated. So kani siya, it's very costly to create a system that would collect the leachate. And it could be a potential for water pollution if dili tarong ang atong leachate collection system. And with this, since landfills kanang dili siya forever kay lisod kayo siya i-maintain with everyday trash and everyday solid wastes, um, landfills could eventually be filled up and makulangan na siya and we will need more landfills to create. So it is not a long-term remedy. All right. So that would be all on solid waste management. I hope you learned something. Thank you.